Okay, so let's start from question number 2 from the exercise 5.5. Exercise 5.5 from question number 2 will we start from here. So question number 2 is we have to differentiate under root of r of x minus 1 into x minus 2 divided by x minus 3 x minus 4 into x minus 5. Okay, so let this is y. We have to find the value of dy dx, differentiate of y. So do one thing, first take log, taking log both sides, we have log y is equal to log of this total term under root of r of, now instead of root we can write to the power minus half, to the power half, x minus 1 x minus 2 by x minus 3 into x minus 4 into x minus 5 to the power half, because root over of x is actually root over of x to the power half, both are the both represent the same thing. Now look, we know a formula that log of x to the power m is equal to m log x. So this exponent will be comes here. So that means log y will be half log of x minus 1 x minus 2 divided by x minus 3 x minus 4 into x minus 5. Now this can be written in the form log y is equal to half of log of x minus 1 plus log of x minus 2 minus log of x minus 3 minus log of x minus 4 minus log of x minus 5. Now differentiate this. Now if I do the differentiation now, so differentiating now with respect to x, we have now differentiating with respect to x, we have 1 by y dy dx is equal to, differentiation of log y is 1 by y dy dx is equal to half. Now what is the derivative of log of 1 minus x, x minus 1? So it will be 1 by x minus 1 plus derivative of x minus 2 is 1 by x minus 2 plus, not plus, minus derivative of log of x minus 3, that is 1 by x minus 3 minus derivative of log of x minus 4, that is 1 by x minus 4 minus 1 by x minus 5. Now from here calculate the value of dy dx, which is y into half into this total expression, x minus 1 x minus 2 x minus 3 x minus 4 x minus 5. Now put the value of y is under root of r of, now put the value of y, that means dy dx is equal to half root of r of x minus 1 x minus 2 by x minus 3 x minus 4 x minus 5 into this total expression, 1 by x minus 1 1 by x minus 2 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. So this is the derivative of the given expression, and hence This is the answer. Okay, now tell me, do you have any problem? Just make a comment whether you have understood or not. No problem. Okay, so now let's move to the next question, question number 3. I'm wrapping this. Question number 3 is log to the power cos of x. We have to differentiate log to the power log x whole to the power cos x. Clear? So let us consider this expression as y. So y equal to log x to the power cos x. Now we have to differentiate it. So do one thing. First, taking log both sides, we have log y is equal to log of this total expression, log x to the power cos x. That means log of y is equal to, now we know log of something whole to the power means this terms will be comes in front of log x. So it will be cos x into log of log x, cos x into log of log x. Now we can differentiate it with respect to x. So now if we differentiate with respect to x both sides, what do we have? We have derivative of log y, which is 1 by y dy dx is equal to, now derivative of this. Now look, this is actually product of two functions. This is the first function and this is the second function, and I think all of you know the derivative of u into v, derivative of u into v, where u is the first function and v is the second function. It is u into derivative of v plus v into derivative of u. We are going to apply this formula here. So u means cos x into derivative of this log of log x plus second function constant means log of log x is constant into derivative of the first function means the cos x. That means 1 by y dy dx is equal to cos x into, now what is the derivative of log x? So derivative of log of this is 1 by log x into derivative of log x, which is equal to 1 by x, plus second function means log of log x into derivative of cos x, which is minus sin x, which is minus sin x. Now if I multiply both sides by y, so we have dy dx is equal to y into cos x by x log x minus sin x into log of log x. Now put y equal to this expression. In place of y, put log x to the power cos x. You will got your answer. Okay, now tell me, have you understood? Students, have you understood? Yes, sir. Okay. Then let's move to question number 4 then. Okay. Question number 4 is differentiate x to the power x minus 2 to the power sin x. Differentiate x to the power x minus 2 to the power sin x. Okay. So let us consider this expression as y. So y equal to x to the power x minus 2 to the power sin x. Now here we are considering u equal to x to the power x and v equal to 2 to the power sin x. We are putting a u instead of x to the power x, and we are putting v instead of 2 to the power sin x. So, these equations will be y equal to u minus v. Okay. Now, differentiate this expression with respect to x. So, dy dx will be equal to du dx minus dv dx. This is our equation number 1. Now, look, if anyhow if we can calculate du dx and dv dx, and if we put them in equation number 1, we have the value of dy dx. So, our task is to calculate the value of dy dx and dv dx from these two equations. Now, look, here it is given as u equal to x to the power x. Now, if I take log, so log u equal to log of x to the power x. That means log u equal to x log x. Now, look, if I now do the differentiation of this function, so we have 1 by u into du dx is equal to, now differentiate this. This is actually product of two functions, one is x and one is log x. So, if I differentiate it, so it will be first function into derivative of second function, and we know that the derivative of log x is 1 by x, plus second function into derivative of first function. First function is x, so derivative of x with respect to x is equal to 1. So, it is 1 plus log x, 1 plus log x. Now, 1 by u du dx equal to 1 plus log x. So, what will be the value of du dx? So, the value of du dx will be u into 1 plus log x. Now, put the value of u as x to the power x, 1 plus log x. So, this is the value of du dx. By similar way, we will calculate the value of dv dx. So, look, v is given 2 to the power sin x, take log both sides. So, taking log, we have log v equal to log of 2 to the power sin x, means log v is equal to sin x into log of 2. Now, differentiate this with respect to x. We have 1 by v dv dx is equal to, so log u is a constant term, log 2, so log 2 into derivative of sin x, which is equal to cos x. So, log 2 into cos x. Now, dv dx equal to, it will be v into log 2 into cos x. Now, put the value of v, that means 2 to the power sin x into cos x into log 2. So, this is the value of dv dx and this is the value of du dx. So, if I put these two value into the equation number 1, so from equation number 1 we have dy dx, it was du dx means the value of this x to the power x 1 plus log x plus dv dx means this 2 to the power sin x into cos x into log 2. So, this is the derivative of the given function y equal to x to the power x minus 2 to the power sin x. Okay, tell me, any problem from your side? Any problem from your side? No, sir. Okay. Then I am skipping two questions. Okay, and question number 5 and question number 6. I am skipping these two questions and I am going to question number 7 now. Okay, I hope you can solve question number 7 and 6. Actually, I am leaving them as a homework, not actually homework. Try to solve it by yourself. Okay, and if you can't, then in my next class, tell me, I will solve it. Now, question number 7. Question number 7 is x to the power sin x plus sin x to the power cos x. We have to differentiate it. So let us consider y equal to this expression, and by similar process we will consider this is u and this is v, and separately we will calculate du dx and dv dx, okay, as we have done in the previous question. So let us consider u equal to x to the power sin x and v equal to sin x to the power cos x. Now from here, if I do the differentiation, so du dy dx, it will be du dx plus dv dx, du dx into dv dx. So let us numbering. This is equation number 1. Now start with this. We know u equal to x to the power sin x. Taking log, we have log u equal to log of x to the power sin x. That means log u equal to sin x log x. Now differentiate it with respect to x. So if I differentiate this with respect to x, we have 1 by u into du dx. That will be equal to sin x, means first function into second derivative of second function, which is 1 by x, plus second function fixed into derivative of first function, that is equal to cos x. So sin x by x plus log x into cos x is the value of 1 by u du dx. Now then what is the value of du dx? So that is u multiplied with this. So value of u equal to x to the power sin x into this log x into cos x. So this is the value of du dx. But similar way, calculate dv dx. So v equal to sin x to the power cos x. Now take log. So taking log, we have log v equal to cos x into log of sin x. Cos x into log of sin x. Now differentiate it with respect to x. So 1 by v into dv dx is equal to. So this is the first function into derivative of second function, that is sin x into cos x, plus second function fixed, means log of sin x is fixed, and derivative of cos x, which is minus sin x. So this is the value of 1 by v dv dx. Now then what is the value of dv dx? So that is v multiplied by this. So v equal to sin x whole to the power cos x multiplied with this expression, that is cos x cot x minus log of sin x into sin x. Okay, now they put these two value in equation number 1. So if I put them in equation number 1, we have dy dx equal to x to the power sin x, put these two value, into sin x by x plus cos x into log x plus dv dx, means this value sin x to the power cos x multiplied with cos x cot x minus sin x log of sin x. So this is the answer. Okay, any problem? No sir. Okay, so then after 7 let's solve question number 11. Okay, question number 11. Question number 11 is differentiate this expression x cos x to the power x plus x sin x to the power 1 by x. So we have to differentiate this expression. So let us consider y equal to the given expression, and we consider this y as sum of two expressions u and v, where u equal to this x cos x whole to the power x and v equal to the second expression x sin x whole to the power 1 by x. Now if I differentiate this expression with respect to x, so we have dy dx is equal to du dx plus dv dx. Let this is our equation number 1. Okay, now from this equation we'll calculate the value of du dx, and from this equation we'll calculate the value of dv dx. So we are starting from u. So u equal to, it is given x cos x whole to the power x. Now first take log. Taking log, we have log u is equal to x into log x plus cos x. Okay, now differentiate it with respect to x. We have 1 by u du dx is equal to, now look, this is the first function and let this is the second function. So first function is fixed, and definition of that will be log of, and differentiation of this term, it will be 1 by x minus 1 by cos x into sin x. That means du dx is equal to u into x 1 by x minus tan x. Now put the value of u as x cos x to the power x. So du dx is equal to x cos x whole to the power x into x, okay, into that is 1 minus x tan x. So this is the value of du dx. By similar way we will calculate now dv dx. So v equal to, it is x sin x whole to the power 1 by x. Now taking log, we have dv dx is equal to 1 by x into log of x plus log of sin x. Okay, now differentiate it with respect to x. So if I differentiate it with respect to, we have 1 by v into dv dx is equal to, sorry, this is log v equal to 1 by v dv dx is equal to, first function is fixed and the derivative of second function, that is 1 by x plus cos x by sin x, plus, now second function will be fixed, means log x plus log of sin x into derivative of first function. So what is the derivative of 1 by x? Can you tell me what is the derivative of 1 by x? Who can answer? Derivative of 1 by x. Yes, it is minus 1 by x square. So minus 1 by x square. Okay, so just do more calculation. So dv dx is equal to v into this expression. So 1 by x square plus, this is cot x by x, cos x by sin x, means cot x by x, minus, if I multiply this expression by x, 1 by x square, so it will be log x by x square minus log of sin x by x square. Now in place of v, put x sin x to the power 1 by x. So if I put that, so derivative of dv means derivative of v means dv dx will be x cos x, sorry, x sin x to the power 1 by x into this total expression, means cot x by, sorry, 1 by x square plus cot x by x minus log x by x square minus log of sin x by x square, log of sin x by x square. Now we have to put the value of du dx and dv dx in equation number 1. We got the answer. Okay, so just put the value of du dx, which is x cos x to the power x into 1 minus x tan x, plus dv dx means this x sin x to the power 1 by x into 1 by x square plus cot x by x minus log x by x square minus log of sin x by x square. You put it in equation number, you got the answer. Okay. Okay, then. Okay, so now let's solve one more problem from here. Okay, so question number 12. After 11, question number 12. Find dy dx. Find dy dx in the given expression x to the power y plus y to the power x is equal to 1. So from this expression, this equation, we have to find the value of dy dx. So let us consider u equal to x to the power y and v equal to y to the power x, and we put these two value in this equation. So from this equation we have u plus v is equal to 1. Now if I differentiate this expression with respect to x, we have du dx plus dv dx is equal to derivative of 1 is equal to 0. So this is equation number 1. Now what is the u? U equal to x to the power y. So differentiate it. So okay, first take log. So log u equal to y log of x. Now differentiate it. So 1 by u du dx is equal to So first function y is constant into derivative of second function, which is equal to 1 by x, plus second function is constant, that is log x into derivative of y. So we are denoting y as a derivative of y as y1. dy dx is sometimes denoted by y1. Okay, so we are denoting y1 instead of dy dx. So what is the value of du dx here? Du dx is equal to u, which is x to the power y into y by x plus log x into y1. So this is the value of du dx. Similar way, calculate dv dx. So taking log, we have log v equal to x log y. So differentiating with respect to x, we have dv dx is equal to y to the power x into first function into derivative of second function plus second function into derivative of first function. Okay, if I have given few step jump here. Okay, so that will be the value of dv dx. So now if we put the value of du dx and dv dx in equation number 1, so we have, so look, we have from equation number 1 x to the power y into y by x plus log x into y1 plus this y to the power x into x by y y1 plus log y is equal to 0. Now from here we have to calculate the value of y1. Okay, so first remove the bracket. So it will be y into x to the power y by x plus x to the power y log x into y1 plus, now if I multiply this, that will be y to the power x into x by y into y1 plus that will be y to the power x log y is equal to 0. Now look, there are two terms containing y1, one is this and one is this. So from these two terms take y1 common. So if I take y1 common, so y1 will be x to the power y log x plus y to the power x into x by y is equal to, now if I write the other two expression on the left hand side, it will be y to the power x log y plus y into x to the power y by x. Now calculate dy y1 means write this expression on the denominator on left hand side, we'll get the answer. Okay, so up to this today up to this, next day we'll continue from question number 13. Okay, now tell me, do you have any problem? Otherwise we'll stop for today. No problem, very good. Okay, keep practicing the problem. Okay, you can see the problems are very large in shape, but if you understand the logic how to solve them, it is very easy. So keep practicing the problem. Okay, then see you next day. Bye bye.